So we made it. We're on day 3 of 5.5, and we're finding complex zeros of quadratic functions. So first, what are complex zeros? Complex zeros are the x-intercepts of a function that will be imaginary. So we have some steps to find complex zeros of a quadratic function. We're going to use our completing the square steps to solve. So remember that the leading coefficient, so that would be the a, so a must equal 1, and it must be a positive 1. The first step we do is we set the equation equal to 0 if it is not already, and if the leading coefficient is not equal to 1, divide it out. So again, this should say 1. Awesome. So the second step here says move the constant term to the other side. Write the equation in the form x squared plus bx plus blank equals blank minus c. And the third step, we're going to fill in those blanks with b over 2 squared and the other blank as well. The last step here is to factor the left side and clean up the right side and then solve by undoing. So again, like I said, we're going to use the same steps we took in completing the square. Find the zeros of the function. So the first thing we're going to do is set it equal to 0. 0 equals x squared minus 2x plus 5. So then we want to move our constant term over, minus 5. And then this is the part where we add the blanks in. So we have negative 5 plus blank equals x squared minus 2x minus blank. So now to figure out what we want to put in the blank, we do b over 2 squared. And we know that our b is equal to negative 2, so we're going to have negative 2 over 2 squared, which is 1 squared, negative 1 squared, which is just equal to 1. So we're going to fill in 1 to each side. So now we're going to clean up the left-hand side. We have negative 4 equals x squared minus 2x minus 1. So then we want to factor. So we'll make our t-chart over here. So it multiplies to negative 1 and adds to negative 2. Oh, this is a positive 1. We're adding 1. So we have negative 1 times negative 1 and negative 1 plus negative 1. So what we really have here is negative 4 equals x minus 1 squared. Now we solve by undoing, so we square root both sides. And this is where we have our imaginary numbers. We have the square root of a negative 4. So what we really have is x minus 1 is equal to, and I want you to remember that the square root of negative 4 can be written as the square root of negative 1 times the square root of 4. So really that's plus or minus 2i. So we have plus or minus 2i. Add 1 to both sides. So our solution here is going to be x equals 1 plus or minus 2i. We're going to do the same thing here. This one we don't need to set equal to 0, but we do need to get that x term over to the right, so we're going to add 4x. And then we're going to want to subtract 13 to both sides as well. So I'm just going to do that at the same time. So we have negative 13 plus blank is equal to x squared plus 4x plus blank. Now let's find our b over 2 squared term. We know that b is 4, so we have 4 over 2 squared, which is the same thing as 2 squared, which is 4. So we're adding 4 to both sides. Add 4, add 4. So now what we do is we clean up the left side. So we have negative 9 is equal to x squared plus 4x plus 4. So we'll set up that t-table to figure out. They need to multiply to 4 and add to 4. So there'll be 2 and 2. So then what we have really is negative 9 is equal to x plus 2 squared. And again, this is where it comes into play that we have imaginary numbers when we square root both sides. So remember that the square root of negative 9 is actually a square root of negative 1 times the square root of 9, which is 3i plus or minus 3i. So we have plus or minus 3i is equal to x plus 2. Subtract 2, subtract 2. So our final answer here is going to be x is equal to negative 2 plus or minus 3i. So now I want you to try the U-try problems, solving the equations and finding the zeros of each function. And again, don't forget to write your summary. Have fun!